Good evening. Today we are going to solve one problem that is on compression member. Last video we are already with the theory of compression member, and now we will go with a double angle section. So now we have problem. Determine the compressive strength of two ISA 95 125 95 by 10 used at used as a strut in a truss for the following two cases. The length of the strut between the intersection is 4 meter. Angles are connected on opposite side of gusset plate, and second angles are connected on same side of gusset plate. So we have to go for these two cases. In both the cases, longer leg connected to the gusset plate. Now we have first case, angles are on opposite side of gusset plate. Properties of the section. So this is given. So if we will go to this IS 808, and in that code you are going to get these properties. So I have taken that table, and we are interested with these values. That is 12510. So area you can see 21.1 centimeter square. So I will get it at 2110 millimeter square. Then if we will go ahead, then you can see this. We are going with same, and then we are with IX 328, IY 164 centimeter 4. So into 10 raised to 4, and then we have RX 39.5 millimeter, RY 27.9 millimeter. So these values we have copied from this. So RZZ we have 39.5 and RYY 27.9. So actually in new IS code, instead of this RX, they are considering it as RZ. Then we have L, that is 4000 given between the intersections. Y we have 164 into 10 raised to 4 into 10 raised to 4, because we have converted it millimeter square. So these are the values which we have taken from IS code. Now we have effective length. We have seen clause number 7.5. In that one we have seen effective length for a double angle section, that is between 0.85 to 1 into L. So we have taken 0.85 into 4000, 3400 millimeter. Then we have section in this way. We have this as longer leg, that is 125. We have this as 95, and then we can have this section. You can see this now. So for longer leg we have this CY, and for shorter edge leg, and for longer leg we have value as CX. This is from thickness side, and that we have to consider when we are going to solve this. So that shows my value, my YY, individual YY will be here, and that we have to shift to the center. Now we have assumed this thickness of the gusset plate as 12 mm. So whatever we have angle section, we should have greater than that thickness of the gusset plate. Now this value we have, that is CYY, and this is given 27.9. And where we have to shift it to the center of this. So we have this as 12. So half we will get it as 12 by 2, and that will be 6 millimeter. So distance between individual YY to the YY of whole section, we have 27.9 plus 6. That will be my value of H. So H I will get it as 27.9 plus 6, and that we will get it as 36.9. Sorry, 33.9 millimeters. And that we are going to consider when we will go IYY of whole section. Now you can see, we have to see, now we have RYY 27.9 and we have RZZ 39.5 millimeter. When we have equal section, then my RZZ is equal to RYY, and we have that will be the minimum. But when we have unequal section, so we have RYY less, we have to find RYY of whole section, and we have to check RYY of whole section is less or RZZ is less. Now we can go with this. This is basic formula. IYY of whole equal to IYY about CG plus A into H square. Now IYY of whole we have 2 times IYY of CG. Why 2 times? Because we have double angles, so 2 angles, and therefore we have taken this. This is IYY of individual. This is area of individual. And this already we have seen. And from this we will get I by of whole. Then R by of whole equal to under root of I by of whole upon AW. That is area of whole section. So 2 times. And from this we will get value 43.89 R by whole. Another, if we will derive this one, then we are going to divide by A, and from this we will get R. So we have R by whole square equal to R by square. Now this I can say it as individual. And then we have plus h square. A gets cancelled, and from this we are going to, and this will be I by A, we have R square. And from this we are going to get value of R by whole square equal to 27.9, which is individual, plus 27.9 plus 6 whole square, and we will get this value 43.9 millimeters. So this formula you can keep in mind, which will be easy for us to solve the problems. And h will be the distance between individual y to the whole y section. Now this value is greater than 93.39.5 millimeter. So my R minimum equal to RZZ equal to 39.5 millimeter. Then I will find value of lambda, which will be L effective upon R minimum 3400 upon 39.5, which will be 86.08. And then using our table 9C, because we have this as angle section, and for angle section we have seen that is from table 10 we have class for all except I section, for all rolled section we have class is C, and therefore we have taken 9C, and from 9C we are going to get this table, and our value we have to find out for 86.08. Now you can see this, we have taken 120 and we are going down. That means my value is going to be minus. So 120 minus, so difference of these two, 120 minus 108, and difference of these two means we are going to get this value, that is for 1 unit KL upon R. And we have how much KL upon R? So 86.08 minus 80. And from this we will get value of FCD 112.70 MPa. You can go another way. So I can go in this way also. FCD is equal to 108 plus, then we have this value as it is 120 minus 108. Then we have divided by down denominator also we have same, and then change we have over here. Now here we have 90 minus 86.08. 90 minus 86.08, and then again you will get same value. You can calculate it and you can check it, and that is 112.70 MPa. So if I will go up, then I have to add it because it is increasing, and down we have to subtract it. Now whatever this value we are going to take, that you have to consider here. It is 80 or it is 90. So here I have taken 120. 120 is related with 80, and I have taken 108. 108 is related with 90. Whichever is greater, that we have to put before, and lesser we have to put it afterwards. And then we have to check this from table 2, which is now on page number 18. And then we have B75, and sorry, we have D, that is 125 millimeter. And then we are going to substitute this B by T, 95 by 10, 9.5 less than 15.7, 125 by 10, 12.5 less than 15.7, and B plus D by T, and that is 95 plus 125 by 10, 22 less than 25. So all criteria are satisfied. Therefore, section is semi-compact section. So we have semi-compact section means AE equal to A, and then we will have AE equal to 2 into 2110, 4220 millimeter square. And we know that is in 7.1 we have PD equal to AE into FCD, and we will substitute values of both, and from this we will get value of compressive strength of the member when it is connected on opposite side of gusset plate as 517.79 kilonewton. So now similarly we will go for second case. Now in this second case my properties are as it is, but now you can see this effective length. Now here we have 4000 because we have connection with longer leg, we do not have connection with shorter leg. So I have directly length as it is 4000 millimeters. Now here you can see I have this as YY section, I have this as XX. My individual XX will be here, and that this will be CXX, and we have this is CYY. Now individual CYY and CYY of whole section are same, so we need not require to find value of RXX of whole, because Rxx of individual is already greater than Ryy. So our R minimum is Ryy. And then we are going to get R minimum Ryy equal to 27.9 millimeter. And then lambda, we have 27.9. 4000 upon 27.9 is 143.37. And again from table 9C, we can find value of FCD in the same fashion. So we have taken 62.9 higher value. So we are going to subtract it. And from this, we are going to get this value that is equal to 60.78 MPa. And then in the same fashion, we will put in the equation PD equal to A into FCD. It will give us 256.49 kilonewton. So likewise, we have to solve the problems when they are connected on opposite side or on same side. When we have equal angle section, that problem becomes very easy. We have to take directly value of R minimum equal to RZZ equal to RYY because both values are same. So thank you. We will stop here only.